Section 2.6 is on inverse variation graphs. So we looked at direct variation graphs last time. So today we're going to look at y equals k divided by x and y equals k divided by x squared. So first let's take a look at y equals k over x. So our two examples are y equals 24 over x and y equals negative 24 over x. So what I would like you to do is pause the video and complete these first two tables and plot the points, but do not connect the dots. So hopefully at this point you have figured out that the table should be negative 6, negative 8, negative 12, negative 24. And at 0, this is a really important point. I want you to notice that this says 0 and DNE for does not exist, because you cannot divide by 0. That is an undefined value. So I really want you to make sure that right here you have either undefined or does not exist. You cannot have 0, 0. And then the table repeats on the positive side with positive values. So if you graph those, then this is something that you should get. What I want you to notice when you graph these inverse graphs is that there's kind of two parts to the graph, because there's a hole in the graph right here at where x is 0, because you cannot divide by 0. So I kind of call it like a little electric fence. The graph does not exist there. So your graph is getting really close to the y-axis and the x-axis as well, and then it jumps, and then it picks up over here, and then it goes down really far, and then again jumps. So this has two different branches is what it's called. And if it is a positive k value, if k is greater than 0, then the branches are in quadrants 1 and 3. So every graph will look something like this. It just might be more steep or more gradual, but it will always be in quadrants 1 and 3. If we take a look at negative 24 over x, we get something similar, except the negative value switched it, so our positive values come first. Again, at 0, we have a does not exist value, or a undefined value, because you cannot divide by 0, and the negatives flip. So when we graph it, we have branches similar again, but now they are in the opposite quadrants. So notice when we are looking at our inverse graph here, k over x, that the branches are always diagonal from each other if it is just over x. And if it is negative, then the branches are going to be in quadrants 2 and 4. So if we talk about the properties of this graph, it's called a hyperbola. So anything in the k over x form is called a hyperbola. And the domain and range are both going to be x cannot equal 0 and y cannot equal 0. That again is for those electric fences where the graph is approaching but never intersecting or crossing. We do have some symmetry lines here, so if I go back and show you, the symmetry lines are going to actually be diagonal lines going through 0, 0 right here. So if you reflected over that pink line that I just drew, your graph would land on itself, and also this other pink line would be a secondary option. So if I put these diagonal lines in here, those would both be symmetry lines. So the equation for this positive one over here is y equals x, and then over here would be y equals negative x. So this equation, this graph, has two different symmetry lines at y equals x and y equals negative x. Sometimes it's helpful if you draw those in on your graphs, on your notes, so that you can see those symmetry lines. The visual is nice. You can just leave them as dotted lines. The next vocab word talks about asymptotes. So the x-axis with the equation y equals 0 is the horizontal asymptote. And then the y-axis with the equation x equals 0 is a vertical asymptote. And the asymptotes are not part of the graph. So again, if I go back and look at the graph and give you a visual, your asymptotes, if I give you, I guess, another color here, a big red line, the graph is getting really close to both y equals 0 and x equals 0 here. And the graph is getting close and approaching, but never going to intersect or touch. So those big red lines I drew are called your asymptotes, because the graph does not intersect or touch them. So those are your properties of the hyperbola. Now let's take a look at your inverse square curves, which is in the form y equals k over x squared. So again, why don't you pause the video and fill out these two tables using the equations 24 over x squared and negative 24 over x squared. Okay, so hopefully by now you've filled out your table and it looks the same as mine. And again, at 0, you have another does not exist or undefined. Now what happened here is with the x squared, I have all positive values. And you can see the symmetry, the 1.5, the 2 2/3, the 6, and the 24. That symmetry looks similar to a parabola. So what's going to happen now is those branches are now symmetrical to the y-axis, and they are side by side. So the difference between the k over x and the k over x squared is the branches are now side by side or symmetrical to the y-axis. Again, they are going to get really close to this x and y-axis, but they are never going to cross or touch the x and y-axis. So again, I kind of think of an electrical fence going down the middle there and coming across here. So those are what your positive k over x squared look like. So again, you're going to have branches in quadrants 1 and 2. And then if I look at the negative 24 over x squared, now all my values are negative, and again I have a 0 does not exist or undefined, and again they're symmetrical, but now because they're all negative values, it's going to be down in this 3rd and 4th quadrant for my branches. So same asymptotes at the x and y axis, symmetrical again, but now they're all negative. So the properties for this are called an inverse square curve. So just exactly how it's written, inverse square, and then the graph is a curve. But now my domain and range are going to be different. My domain is still going to be x cannot equal 0, but my range has to change depending on if my k value is positive or negative. And it changes if we go back and look, because this positive one, the graph is only above 0. It never comes down here. And on the flip side, when my k value was negative, it was only below the y-axis. So I need to change my range depending on which k value I have. Again, that's similar to the parabola. This symmetry I talked about already. It has one line of symmetry at the x equals 0 line, which is considered your y-axis. And the asymptotes again are same as the hyperbola. So I have x equals 0 with the equation the x-axis with the equation y equals 0 is a horizontal asymptote, or the y-axis with the equation x equals 0 is a vertical asymptote. And again, the asymptotes are not part of the graph. So no matter which inverse variation graph you're looking at, the asymptotes are the same, and a lot of the properties are similar. It just depends on if you have an inverse square curve, those graphs are going to be side by side. If you have a hyperbola, they're going to be diagonal from each other. This is going to be something that you're going to need to be able to graph without using your graphing calculator, so really work on using the table to plot the points and knowing the general form of the graphs. So those are your 2 variation graphs.